Let's take a look at this through the lens of a problem. It says, let be the amount spent on books in the fall semester for a full-time student in OCC. Suppose that the mean amount for books is 153 and the standard deviation for the amount of books being purchased is 32. Let C be the overall cost for tuition and fees for a randomly selected student, and tuition and fees on average is 832, and it has a standard deviation of 103. It says find the mean and standard deviation of the cost of tuition fees and books for a randomly selected student at OCC. Well, let's see how we can do that. We're creating a new random variable. I'm going to call it T for total, and it's C plus B. The mean of T is equal to the mean of C plus the mean of B, which in this case is 153 plus 832.50. And if I add those together, I get 985.50, and the units there are dollars. Great. Let's look at the variance of T. Remember, we can't do the variance of the standard deviation directly, but we can add the two variances up, which is going to be 100. I have these backwards. This is books, and this is cost. This is books, this is cost. And so the standard deviation of books is 32. Let's square that to get a variance. And the standard deviation of cost is 103. Let's square that to get the variance. And if we put that into our calculator, let me switch over to our calculator, create a new document, calculator document, 32 squared plus 103 squared gets us 11,633. And then therefore the standard deviation of that will be the square root of 11,633. So I'll put in square root, and I'll type in 11,633, type it in right, control enter in order to get the decimal version, 107.86. 107.86, and that's in dollars. So there's our standard deviation and mean for the combining of these two random variables. All right. Let's go back to Pete and Aaron. Says earlier we defined X as being the number of passengers on Pete's trip, Y the number of passengers on Aaron's trip. C was the amount of money that Pete collects on an individual day. That was, by the way, C is equal to, I think he gets $150 per passenger. So we can think of P as a random variable that's found by taking 150 times X. Aaron charges 175. So her amount taken in G could be found by taking 175 and multiplying it by the random variable Y. Says find the mean and the standard deviation of G. Well, the mean of G, as we found out earlier, is the transformation of the mean of Y, which is 175 times that mean, which is 3.10. And let's go over here, 175 times 3.1, and that ends up being 542.50. 542.50, and that unit is in dollars. Okay, what about the standard deviation? Remember, the standard deviation of a transform variable is the multiplier times the old standard deviation, which in this case would be 175 times the 0.943. hopefully I multiplied those right, and we get 165.025, and that unit is in dollars. Okay, so that's a little blast from the previous lecture. Oh, but what happens when we collect or find the mean and standard deviation of the combined money that Aaron and Pete collected? Well, let's call this some new variable. Um, okay. Well, first of all, we're going to need the new variable. I'll call it M, and it's going to be C, which will be the amount of money captured by Pete, and then G, the amount of money captured by Aaron. And what did we say? The mean of M will be the mean of C plus the mean of G, right? Well, the mean of C we had up here, 562.50, and the mean of G we find right here, 542.50. And if we add those up, 0 plus 0 is 0, 5 plus 5 is 0, carry the 1, 3 plus 2 is 5, no carry, 4 plus 6 is 0, but carry the 1. It looks like it's $1,150. All right? $1,105. All right. But what about the standard deviation? Well, can't do it directly. We got to do the variance. So this is going to be the variance of C, variance of G. We found that the standard deviation of C was 163.50. We're going to square that, and we're going to add to it the variance of G, which is 165.025 squared. All right. Okay. So 163.50 squared plus 165.025. We'll square that, add them up, and there's our variance of M, which is 53,965.50. And in order to find the standard deviation, of course, we'll have to take the square root of that, 5365.50. So we'll take the square root of that number, and we get 232.31. 232.31, and that's in dollars, and the mean is also in dollars. So we put those units on there. All right. So now we're finished. Are we finished with Aaron and Pete? No, because we also want to look at what happens if we look not at the a sum of the two random variables, but what if we look at the difference of the two random variables? All right. And we're going to do this a little bit more quickly. If we create a new random variable by taking one random variable and subtracting the other, then the expected difference or the mean of the differences is going to be the differences of those two means. The surprising thing is that what happens when we try to find the variance and the standard deviation of this distribution of differences? And it says if you have these two random variables, finding a new random variable by subtracting one from the other, you will still end up adding the variances. So it's not intuitive, but remember, variances can never be negative. So by having it positive, you're never going to end up with a negative value for the variance. And that's what the formula is. So in the case of finding out what's the difference in the amount earned between Aaron and Pete, so well, let's create a new random variable. Pete's revenue minus Aaron's revenue. If we ask for, well, what's the mean of those differences? That will be the mean of Pete's revenue minus the mean of Aaron's revenue, or 542.50 minus, sorry, try that again, 562.50. There's Pete's revenue minus 542.50. There's Aaron's revenue for a difference of $20. What does that mean? Well, it means that over many, many trials, pulling one value from Pete, one value from Aaron, on average, the two earnings will vary by $20. What about the standard deviation of that difference? Well, we can't do standard deviation directly, so we're going to have to do the variances. So the variances are going to be 163.50 squared plus 165.03 squared. Oh, wait, this is exactly the same thing we had before. That number was 53,965.50. And of course, the standard deviation will be the square root of that, which we found earlier to be $232 and 31 cents. Okay. All right. So differences, again, found by, you find the mean of the difference by subtracting, you find the variance of the difference by adding. Okay. So to sum up, the standard deviation of Pete and Aaron was $232.31. So even though the average difference is $20, the difference for an individual days may vary a lot. How much? Well, by $232.31, $232.31 on average. All right, let's go ahead and try some other situations. We did all of these examples using a discrete probability distribution, but just know that all these rules apply also to continuous random variables. For example, Mr. Starnes likes sugar in his hot tea. From experience, he needs between 8.5 and 9 grams of sugar in a cup to make the tea taste right. While making his tea one morning, Mr. Starr adds 4 randomly selected packets of sugar. Suppose the amount of sugar in the packets follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. What's the probability that Mr. Starnes' tea tastes right? Well, first of all, let's acknowledge that X, the amount of the amount of sugar in an individual packet, is normally distributed with a mean of 2.17 and a standard deviation of 0.08. Okay, if that's the case, each of these random numbers, the amount coming from the first packet and the amount coming from the second packet and the amount coming from the third packet and the amount coming from the fourth packet, they are all random numbers coming from that same normal distribution. So our question is, well, what's the sum of 4 of those packets look like? In other words, what is T x1 plus x2 plus x3 plus x4 look like? Well, first of all, we know that it'll be normal because all these packets are coming from normal distributions. Secondly, the mean will be the sum of these means. Sum of x sub 1, the mean of x sub 2, the mean of x sub 3, the mean of x sub 4, which ends up being just 2.17 times 4. uh, and that ends up being 8.68 grams. So on average from these four packets, we're going to get 8.68 grams of sugar. But what about the variance? Well, the variance of T will be the variance of x sub 1 squared, sorry, the variance of x sub 1, the variance of x sub 2, the variance of x sub 3, and the variance of x sub 4, or it's going to be 0.08 squared, and because we're adding them up four times, we'll multiply that by 4, and that ends up being 0.0256. Now, if you want the standard deviation, well, you're going to have to take the square root of 0.256, and that ends up being 0.16, and that unit is in grams. So, in summary, the amount of sugar in Mr. Starnes' tea centers around 2.68 with a standard deviation of 0.16. If we go up one standard deviation, that's 8.84. If we go up one more standard deviation, that'll be 9 even. If we go down a standard deviation, we're at 8.52, and one more standard deviation, we're at 8.36. And we're interested in Mr. Starnes' tea tasting right, which puts us somewhere in this range from 8.5 to 9.0. And so that area is the probability that his tea will taste right. And again, reminder that tea has to be normally distributed with that mean and that standard deviation. If you want full credit on the AP exam, by the way, it's really important to do this groundwork and explicitly say that you're using that normal distribution. Now, how are we going to calculate that area? Well, we're going to go to the calculator and calculate, well, what's the probability that T is between 8.5 and 9? And we do that on the calculator. We go menu, probability, distributions, and this is going to be a normal CDF with the lower bound being 8.5, the upper bound being 9, coming from a distribution whose mean is 8.68 and whose standard deviation is 0.16. And we let that fly. So it looks like 0.847 rounding up. This is 0.847. So what's our conclusion? Well, there is an approximately 85% chance that Mr. Starnes's tea will taste right. All right. Let's do one more example. Suppose that the height of males is signified by the random variable m for male speed daters, and it follows a normal distribution with a mean of 70 and a standard deviation of 3.5. And suppose the height of females is normal with a mean of 65 and a height standard deviation of 3. What is the probability that a randomly selected male speed dater is taller than a randomly selected female speed dater for whom or with whom he is paired? Okay, so first of all, let's define what we're after. What is that probability? To do that, we'll use a new random variable d, which will be the height of the male minus the height of the female. And because we don't know the height of the randomly selected male and the randomly selected female, d is also random. And our goal is to find, and this is the hard part, since in general male are taller than female, what we're really asking is what's the probability that the difference is greater than zero? That's our question. What's the probability that the male height is bigger than the female? That's going to happen when the difference is positive. All right. So we need to find out stuff about this distribution D. Well, first of all, how about the mean of D? Well, that would be the mean of the males minus the mean of the females, which in this case is 70 minus 65, or 5 inches. What about the variance? Well, the variance is going to be the variance of the males plus the variance of the females. Again, assuming that these are random and independent. And according to this, 3.5 is the standard deviation of the males. So 3.5 squares is the variance. And that 3 is the standard deviation of females. And so therefore 3 squared is the variance of the females. Let's find out what number that is. Um, 3.5 squared plus 3 squared. Sorry. And that's 2125. And therefore the standard deviation of D is the square root of 2125. And I'll go up there and get that number. And we get 4.6. Let's call it 4.610. 4.610. And that's in inches. All right. So what's the probability the randomly selected male is taller than a randomly selected female? Let's remember that the random variable difference is going to be normal with a mean of 5 inches and a standard deviation of 4.61 inches. So I will draw that out without complaint. There's 5. And then here is about 1 standard deviation up, 4.610. So this is 9.610. Let's go down 1 standard deviation, and that's about 0.4. And here is where 0 is. Here is where the male and the female are the same height. And on this side of the line is when the males are taller than the females. The other side of the line is where the females are taller than the males. So we're asking, what's the probability that the difference is greater than 0? So we'll go to the calculator again. Menu, probability, distributions, normal CDF. Our lower bound is 0. Our upper bound is infinity. So I'll grab the infinity. Our mean was 5, and our standard deviation was 4.61. And we get 86, little over 86%. 0.861. Right? So conclusion, the probability that a randomly chosen male speed dater is taller than a randomly chosen female speed dater is 0.861. or about 86% chance that the male will be taller than the female. All right. And that concludes our 6-2 lecture with these important formulas for combining and transforming random variables.